In the years, the most important topic is trigonometry. That is nothing but triangles. The triangles in chapter 2 and the most important theorem is basic proportionality theorem. Basic proportionality theorem ki inkoka name entante that is also called as a Bayes theorem because it is derived by the great mathematician Bayes. By the name of Bayes, it is also called as a Bayes theorem. The statement of the theorem is, if a line drawn parallel to one side of a triangle to intersect other two sides in distinct points, then the other two sides are divided in the same ratio. So, first of all, after reading the statement, we have to understand the statement is belonging to which type of the figure. The statement is belonging to a triangle. So in this triangle, I am going to draw a triangle. This is a triangle ABC. In this triangle, what is given? A line is drawn parallel to one side of a triangle. So in this triangle ABC, we have to draw a line which is parallel to one side of a triangle. So here, I am drawing the line DE. DE is a line which is parallel to BC. So given a line is drawn parallel to one side of a triangle, so that I am drawing a line DE. This line DE is parallel to side BC. If we draw that line, it intersects the other two sides in distinct points. So this line intersects the other two sides. What are the other two sides here? AB is one side and AC is another side. These two sides are intersecting at a point D and E. Then here, what do we have to prove that here? Then the other two sides are divided in the same ratio. Then the other two sides are divided in the same ratio. That is AD by DB is equal to AE by EC. That is a statement and what we have to do. So first of all, after drawing this diagram, we have to write what is given in the statement. What is given in the statement? A line is drawn parallel to one side of a triangle. That is in triangle ABC. In triangle ABC, DE is a line which is parallel to the side BC. So DE is parallel to BC. DE is parallel to BC. Then what we have to prove? That is called RTP. RTP is nothing but required. We have to prove this line divides the other two sides in the same ratio. Other two sides in the same ratio means we have to prove that AD by DB is equal to AE by EC. So, other two sides are divided in the same ratio, that is nothing but AD by DB is equal to AE by EC. That we have to prove. So, if you want to prove AD by DB is equal to AE by EC by using the similarity of the triangles or the congruence of the triangles, let AD be the side of one triangle. We can see that AD is a side of the triangle ADE. And DB also must be the side of another triangle. DB is not a side of any triangle. So I am joining B and D. To make DB as the side of the triangle, I am joining the sides, the points, the vertices B and D. So here AE must be the side of one triangle. AE is already the side of triangle AED. And EC also must be the side of the triangle. So EC must be the side of the triangle. To make EC as the side of the triangle, I am joining D and C. Then EC is the side of another triangle. So here, whatever the changes that we made in the figure, that comes under the part construction. This construction is nothing but join B to E, comma C to D. So we are joining B to E and C to D. And also we made one more change in the diagram, that is draw EN. Draw EN perpendicular to AD, comma DM perpendicular to E. So these two changes we made here. EN is perpendicular to AD and DM is also perpendicular to A. This comes under the construction. So if you want to prove AD by DB is equal to AE by EC, then we can take area of the triangle. So if you want to prove this, we must know the area of a triangle. What is the area of the triangle? Area of a triangle formula is nothing but half into base into height. If we have 3 points, then the proof will be complete. So what are the 3 we can show here? See in the proof, first point. I am taking area of triangle ABC by area of triangle BDE. Area of triangle, yes, sorry, we can take ADE. Area of triangle ADE. Area of triangle ADE by area of triangle BDE. So we know that area of a triangle formula is half into base into height. So half into, in this triangle ADE, I am taking AD as the base, half into AD into height. Height is EN. Half into AD into EN by. So area of triangle BD. Area of triangle BD half into, I am taking base as a BD. Because base why we are taking BD. So if you want to prove here, in this we are having the side DB. So if you want to get the side DB here also you can take the side DB. Here, but what is the height here? What is the height of the triangle BD? This triangle BD, the triangle seems to be like an obtuse angle triangle. For example, this is an obtuse angle triangle. In this obtuse angle triangle, this is a D. And here it is a B, and here it is E. Whatever may be the obtuse angle triangle, the altitude or height of the obtuse angle triangle must be the exterior of the triangle. So in obtuse angle triangle, the altitude must be the exterior angle of the triangle. That is the exterior side. If we produce the side BD here, then only we can get the altitude in obtuse angle triangle. So same phenomena here we are applying. In this triangle, this is the base and the altitude is nothing but EN will be the altitude. So we can take here altitude is EN. Now we can cancel half here, EN here. Then we get here AD by BD. AD by BD. So area of triangle ADE by area of triangle BD is equal to, we got AD by DB. That is the left side part of the proof. Next, this comes as the first point if you take. Now if you take the second point, area of triangle ADE by, I am taking now area of triangle CED. Area of triangle ADE by area of triangle CED. Why? Because now I am taking here AE as the base. So half into, now I am taking AE as the base, half into AE into, now I am taking altitude as DM. So DM is the altitude, that is DM by half into, in this triangle CED, I am taking CE as the base. Why? Because we have the side CE here to prove. So half into CE into. For this triangle also, altitude will be the exterior of the triangle, so that the altitude is nothing but DM. Now we cancel the equal parts, that is half we can cancel and DM will cancel. Here we get AE by CE. CE is nothing but we can also call it as EC. Both are same one. So this is the first point and it is the second point. Now we have one concept in the 9th standard, that is We see here, this triangle BDE and the triangle CED, both the triangles are on the same base D. For the triangle BDE and the triangle CED, both the triangles are on the same base D and between the same parallel lines DE and BC. If the triangle is constructed on the same base and between the same parallel line, the areas are equal. That we already studied in 9th standard. So the third point, we can say that the third point is nothing but area of triangle BDE. Area of triangle BDE is equal to area of triangle CED. Area of triangle BDE is equal to area of triangle CED. Why? Because the triangles on the same base, triangles on the same base and between same parallel lines. The triangles on the same base and between the same parallel lines. So their areas are equal. So see here from equation 1, equation 2 and equation 3. So numerators are same from equation 1 and equation 2 and the denominators areas are the same. If the denominators areas are same, then whatever we take, this numerator by this denominator, the same numerator by this denominator we are taking, both the denominators are same because their areas are same. So we can write it as AD by DB is equal to AE by EC. This is called as the Thales theorem. So Thales theorem is nothing but in the triangle, if a line is drawn parallel to one side, to intersect the other two sides in distinct points, then the other two sides are divided